Right, good afternoon. So last day we started to work on the cubic, right? We spent some time on the cubic equation and we said a few things. We said that for a cubic equation, ax cubed plus bx squared plus cx plus d, when it's equal to 0, the sum of the roots is minus b on a. We said that the pairwise sum is c on a, and we said that the product is minus d on a. All right, those are some of the things that we did last day, right? All right. Added to this, I wanted to give you two more things that is give you at the end of the they give you on your formula sheet, right? Right. Sometimes they ask you to find alpha squared plus beta squared plus gamma squared. That's alpha plus beta plus gamma all squared minus of 2 alpha minus of 2 alpha beta beta gamma plus gamma alpha. And then in case they ask you alpha beta squared plus beta gamma squared plus gamma alpha squared, that will be alpha beta plus beta gamma plus gamma alpha squared minus of 2 alpha beta alpha plus beta plus gamma. Right, so they will give you this in exam most of the times, but this is not exam, so you have to learn it, right? Right, copy them down. I'll get an example here for you. Right. Right, so these are the little things that you have to learn, right? So we're going to apply them here. Call yourself coming upstairs. Yeah, let's go again. Are you okay with that? Let's go again. Sorry, let's go with an example quickly. Are you okay with that? Well, you can see it, right? Right, for those who now enter the class, write this down fast. Let's take a picture of that. All right, so try this here. Using that cubic, find all those things. I gave you last time, right? A little while ago. Yeah. Look out each one. Not take it too long. We start to work it out. Right. So A is 1, B is 0, C is 4, D is -3. Okay. So the sum of the roots will be minus B on A. That's 0. Pairwise sum, C on A, so that'll be 4. Product, that'll be -3 on A, so that'll be +3. Everybody get up? Yes, sir. Check back and see. Remember, there is no squared term, right? So B is 0. A is 1, B is 0, C is 4, and D is -3. Well, you have to simplify it, sir. Then you could use the formula, sir. What will the numerator be, sir? Well, alpha squared. Well, ideally to be beta squared, gamma squared, right? But the numerator will be alpha squared, beta squared, alpha squared, gamma squared, and the beta squared, gamma squared. Right? Now you can use the formula I gave you. Okay? Now you can use the formula I gave you, right? The denominator is +3 squared. Right? The next one will be the pairwise sum squared minus 2 by the product by the sum. Sorry, this is 0, right? By the sum. So I have 16 on 9. Yeah, understand? Check the formula, the pairwise minus 2 by the product of the roots by the sum of the roots. That's how you just get the formula. Oh, you're not reaching class? Give me the formula now, so you'll see it. Alpha squared, beta squared here. Anybody got 16 on 9? Yeah? Next one is what? Next one is alpha squared, beta squared, gamma squared. And numerator is alpha squared, beta squared, gamma squared. So again, the underneath is 9. And the numerator is what? Alpha plus beta plus gamma all squared minus 2 by which one? Pairwise sum. Nice. Pairwise sum is 4. So I got -8 on 9. Are we okay with that? And then the last one is 1 over the product. 1 over 9. Okay? How we getting the equation now? How we getting the equation whose roots are? Nice. X cubed minus the sum of the roots. What's the sum of the roots? We work it out already. 16 on 9. Nice job. plus the pairwise sum. The pairwise sum is what? No, the pairwise sum is minus 8 or 9. Remember, you're using these new roots now, so the pairwise sum is here. By x minus 1, 9. You can multiply everything by 9 to make it look nice. 9x cubed minus 16x squared minus 8x minus 1 is 0. If I show is 16 on 9, yeah? Number 2, right? Yeah, 16 on 9. Check back and see and just make sure you get that value. Are you okay with this? Provided I give you the formula, you can handle this? Online, are you okay with this? Emily, Amanda, Samira, okay. Copy it down, I want to show you our next method. By the way, you're okay with how I got pairwise sum? Remember, these are your roots, right? These are the new roots. One on alpha squared, one on beta squared. Right, these are the roots, right? These are the new roots. One on alpha squared, one on beta squared, one on gamma squared. To get it pairwise, you pair them up. One on alpha squared, beta squared, plus this by this, plus this by this. Okay, that's the pairwise sum. Okay, so that's method 1, and method one generally works for all the past paper type questions. But I'll still show you our next method if you want, right? Oh, you read the wrong thing, okay. Yeah? What are you writing? Written on Shirish. Take your time, Shirish. Yeah, I don't know what's going on with the camera. That's why I was kind of using code. I was working all the time doing it. Finish now, Shirish? Sure. All right. So the next method looks like this. Remember we had right? Remember we had the equation. Just call it off again. X cubed was the original equation. Plus 4x, right? Minus 5 is equal to 0. Oh, minus 3. Right? And we need to get a new equation with roots 1 on alpha squared, 1 on beta squared, 1 on gamma squared. So here's how we could do it as well. A next way to do it is something like this. So remember alpha squared and beta squared and gamma squared, right? Remember, those are the x values, all right? technically those are the x values. So technically we have 1 on x squared. All right? And 1 on x squared, let's make it equal to some new letter. Let's call it at u or t. All right, let's use u. So, right? So let u equal to 1 on x squared. So what we need to do is develop a new equation in terms of u now. Okay? So the first thing we're going to try and do is make x a subject of the formula. So I can replace all these x's here in terms of u. Okay? So I'm going to try to replace out those x's there in terms of u. So x squared is equal to 1 on u, which implies, Shivish, what would x be? X will be the square root of 1 on u. So x is really 1 over u to the power of a half. Are you okay with that? So what would x cube be? 1 over u to the power of cube everything, right? So it'll be 1 over u to the power of 3 on 2. Okay? So if I substitute now in x cube plus 4x minus 3 is 0, I will end up with 1 over u to the 3 on 2 plus 4 by 1 over u to the half minus 3 is 0. Are you okay with that? But of course, kind of looking like what we have, right? So let's try and remove the denominator. So let's multiply everything by u to the power of 3 on 2. Okay? You'll be left with 1 plus 4 by, what is u to the 3 on 2 divided by u to the half? And that'll be 3 on 2 minus a half, which is 2 on 2, which is 1. Yeah? Are you sure? Minus in, right? One line, follow there still. So you'll end up with 4 by u. So you'll end up with 4 by u minus 3 by u to the 3 on 2 is equal to 0. Right? Trying to make it look nice, right? So we have 1 plus 4u is equal to 3u to the 3 on 2. So I'm going to square up here, and I'm going to square up here so I don't have that fraction anymore. So here I'll get 1 plus 16u squared plus 8u. Right? That's when I expanded the bracket there. Is equal to, I'm going to square the right hand side, and I will get 9u cubed. Everybody okay with that? Now bringing everything on your left side, I'll get 9u cubed minus 16u squared minus 8u minus 1 is 0. Right? So the new equation is, I just changing the u back to x, right? 9x squared minus 9x cubed minus 16x squared minus 8x. Same thing as before. Check and see. Same thing as before. Hey, John? Yeah? All right, so that is what we're trying. That's the next method, which you don't have to use because they'll give you all the formulae. But if in a question they don't give you like what is alpha squared plus beta squared, and you don't remember, use this method. Sorry? It will always be u equal to whatever the root is. And then from there, you find what is x. I'll give you one to try. Don't worry. Don't worry. turn to Arian, yeah. Arian, right on the thing now, boy. Taking a picture and showing on right now. Hmm? Yeah, ready? One, one. No, but egg one. Everybody one. Yeah. Shivish, right answer. All right, Shivish. Take a little picture now. All right. I'm gonna give you one here, but I want you to use method 2 alone. Can't use method 1. This one easier. Anybody here have all the add muscle? What's it for? You have all the add muscles written down? No? What? No, I'm trying to get back I'm noting out some problem. Who? What's she doing now? Oh, can buy you. X cubed plus 5x plus 2 equal to 0 has roots alpha, beta, and gamma. Find an equation whose roots are 1 on alpha, 1 on beta, 1 on gamma. Anybody confused? Comma, right? Anybody confused? Sarah, you okay? I know you're tired, but you can do all this one here. Pardon me? You'll be careful. No. 1 on X. 1 on X. Alpha, beta, and gamma, since they are the same basically form, then that means X could be alpha, X could be beta, X could be gamma. So that new root U is 1 on X. Penetration? Trouble? Right? So that's the end of module 1. Test time to 1. Wait, let's see. Right? Remember when you reach fraction part multiplied out. And a fraction. And a fraction to the end. All right, let's see what we got. One line over there still. I'm not going to rush into module 2 today. Now I'm going to give all their full paper. All right, let's see what you got. U is equal to U is equal to 1 on X. So therefore, X is equal to 1 on U, which also means that X cube is equal to 1 on U cube. So when I substitute now, when I substitute in X cube plus 5X plus 2, I will get 1 on U cube plus 5 by 1 on U plus 2 is 0. Multiply everything by U cube, you'll get 1 plus 5U squared plus 2U cube is equal to 0. And you're good to go. Rearrange it, you'll get 2U cube plus 5U squared plus 1 is 0. Right? And then you could do your replacing, and you will get your equation as 2x cubed plus 5x squared plus 1 is 0. Okay? That brings us to the end of module 1. Right? Let's do a full module 1 now, and then I wouldn't rush into module 2 today. Module 2 trigs. Yeah, one time. I'm spending most of the time on trigs. Because you remember how you add math question trig real small, like one little piece. Now your trig question in unit 2 is a whole question. Right? Vectors? Not 9 past papers. All right, so let's try one of these years here, right? Or do you want to do a paper 2 or paper 1? Two. All right, so let's start here. I think this is 2022, right? Come on. This is paper 2, starting from the topic that we just did, right? I'll share it in the, somebody can share it in the group there. Well, that's the goal. Or let's move kind of slow sometimes. So I hope that will happen. But let's start here. Do that fast. They didn't specify a method, but they gave it some values, right? If you want, you could use the method that I show you. 2D. 2D, yeah. Right? Right? Start with number 2 and go to number. Charity, very good place. Thank you. Let's move on. Paper on the group solid, you can just keep working. Right? Which method to use? This one? Hold on, I think my pen less die. Online, what we have online here. Anybody send you paper? No, nobody send you paper. That's well. I have it somewhere. But yes, say it again, people. Just pull it off, man, please. All right. So I just shared back there what's going on here now, boy. Hold on, it's still not getting my paper. Pen. All right, so this is part D. Which method you said to use? Second method. So x is equal to 1 on u, right? Or technically u is equal to 1 on x. So x is 1 on u. So x squared is 1 on u squared. X cube is 1 on u cube, and so on, right? Well, that's all we need, right? So I'm going to substitute in equation 1 here. So I'll get 2 by 1 on u cube minus 1 on u squared plus 3 by 1 on u minus 1 is 0. So I'll get 2 on u cube minus 1 on u squared plus 3 on u minus 1 is 0. Right? Multiply everything by u cube. So you'll get 2 minus u plus 3u squared minus u cube is 0. You could rearrange it. And you'll get positive u cube minus 3u squared plus u minus 2 is 0. Okay? And then you could replace with x. So you'll get x cubed minus 3x squared plus x minus 2 is 0. Yeah? If you're using next value as a fraction, that's all right. All different, so you leave it as minus plus. Yeah, that's okay. I just like to start my x cubed with a positive. So it don't matter. If you had minus, that's okay. Any questions online? Emily? Oligancho? Right? Let's go again. Emily writing? Try this fast. That remain non-factor, right? Yes, well, I did remain. Yes, we do some remain non-factor, and we do some past papers too. Malaika, you all getting through? Right, so this one is the main non-factor theorem, right? Let's see what you got. Gotta get P and Q, right? So you two unknowns, right? Huh? Same year, I'm Christopher, 2022. Same year we're looking at it. Pick any group, right? Finish? Yeah. Nice. Yeah. All right, let's check out the remainder factor now. Copy anything wholesale, right? So if something divisible by 1, it means that x minus 1, it means f of 1 is 0. If the remainder is 6, it means that f of minus 1 is minus 6. Right? Those are the remainder and factor rules. So when I plug in 1 in here, I'll get 2 minus p plus q minus 10 is 0. So I get in minus p plus q is equal to positive 8. Anybody get that? Equation 1. And then the second equation, minus 1. The second equation is for minus 1. So that'll be minus 2 minus p minus q minus 10 is minus 6. So minus p minus q is equal to minus 12, positive 12, positive 6. Anybody got that? Minus p minus q is positive 6. Yeah? Now we're going to take equation 1 and 2 and add them. Add equation 1 and 2. Calculator. Sorry? And it's minus 6 on the right side. Minus 2. Minus 2 minus 10 is minus 12. When you move minus 12 across, you'll get plus 12, right? 12 minus 6 is 6. Last time I checked. Yeah? So positive p is 14 on minus 2. So that's minus 7. And q is equal to minus p minus 6. So that's 7 minus 6, which is 1. Q is equal to 1. You get that? Right? Let's go again. No, 2 minutes. You're on coming class later already. Continuing. Right, take a twist it, right? Let's go to B. Do your thing. What are looking like? What are looking like? What are looking like? Some kind of what? Logs? Nah. Some kind of quadratic, right? Some kind of disguised quadratic. So we had to find a way to make it look nice. Do your thing. Do your thing. Let me see what you get. Let's figure out something. Figure out a substitution. The hint there already. The hint kind of there. Let y equal to something. So you get the first two right? 1.5. That's good. That's a good start. And you're going to get this one right now. That's 2 out of 3. Right? So think about what can make a substitution. And to all of this, that y equal to 2x to the power 2 to the power of 1. And then figure out what y squared. Four is what? 2 squared. So what is 2 squared? 2x. What is 2 squared? 2x. 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 Yes, sir. That's a focus on that. Right, just to show you the substitution. Just to show you the substitution, right? You could let y equal to 2 to the 2x. Remember that 4 to the 2x is the same as 2 squared to 2x. Because it's multiplication, we can switch it around. These two things are the same, right? And remember, this is y, right? So we'll get y squared. Right? And just rearrange it because you don't want the fraction to work with, right? Right? Rearrange it and solve the quadratic. Remember, you don't want the denominator there, right? We're sleeping in the apartment, but looking okay. Again, so easy. All right, so we should get what? We should get 6 minus 7 over y minus 3 over y squared is 0. You can multiply everything by y squared, and you'll get 6y squared minus 7y minus 3 is 0. When you solve it, you'll get y is how much? Minus 1 over 3. Remember, y is really 2 to the 2x. 2 to the 2x is minus 1/3. This has no solution. That has no solution, right? Now you want to get 2 to the 2x is 3 on 2. Take logs on both sides. You'll get 2x is equal to log 3 on 2 all over log 2, and then you'll get 0.9. Amanda got 0.292. Sorry? Take logs on both sides. Take it 2x, bring it in front, and carry across log 2. Right? So you'll get 2x is log 3 on 2 over log 2, and then you divide everything by 2. Amanda got 0.292. You got that? Yes. All right. And then, well, you can't find next one is negative, right? So that's no solution. That's an easy way. I wonder what was 122? Module 3 probably. I doubt. Module 2 is easier. You can put in a calculator, sir. Taking it off, right? Too bad. Let's go again. Find that first. Find that first. Find the inverse. False. Next one. Find the inverse quick. Easy marks. You do that in your head. Mental. Yeah. You gotta come and do it over. Huh? Yeah, you come and sit down right there. Tomorrow. You're done? Yeah. Kind of weird. Composite function. put G in F prime, in F inverse. No, that O just means multiply. That O just means, I think to find the right font, it just means F of G of X. F prime X, F inverse X. Let's check this out now. Y is equal to 3x plus 1 on X. Cross multiply. Sorry, interchange X on Y. X on 1 is equal to 3y plus 1 over Y. Cross multiply and solve for Y, right? So you'll get 3y plus 1 is equal to xy. Bring all the y's together. And then make y the subject. So y is equal to 1 over 3 minus x. Are you back to front? Oh, sorry. When I carry it across, it says minus 1. Which is the same as 1 over x minus 3. Okay. Can write on the board. That's okay. The next one is a composite function. Real easy. You want f inverse of g of x. Right? So the first thing you do is write what g of x is. G of x is e to the minus 2x plus 1. So all we're going to do is plug in this in f inverse. So that'll be 1 over e to the minus 2x plus 1 minus 3. So the answer is 1 over e to the minus 2x minus 2. If you want to complicate it, you could write 1 on e to the 2x something, right? But they ask for the simplest form. Okay, now. No, I just want the expression. Probably, yeah. Cross multiply and then separate and then probably take long. So all you're doing is just plugging in e to the minus 2x into plus 1 into f inverse. Next one. Wait, now this is one question. We know number one as yet. Oh, we now finished number 2. Yeah, man, look a little modulus here. Yeah, modulus, then logs. But these logs easy, they might change the base. Exam getting easy now, buddy. Shabish, right? Oh, yeah, do the modulus. This is number 1C now. You want to square both sides, go right ahead, right? Anything you want. Huh? All right, so here, when the modulus, or the right, so when the modulus, saying the wrong thing, sorry. When 3x plus 2 is more than 0, then you will get positive 3x plus 2 is more than or equal to 4. 3x plus 2, 3x is more than 2, x is more than or equal to 2/3. When 3x plus 2 is less than 0, then we use the minus in front. Right, carry across the minus sign. If you want to, it's up to you. You can leave it here. Carry across the minus 2. You'll get positive 6. Now, when you divide everything by minus 3, the inequality sign will change. So you'll get x is less than minus 2, but x is more than 2/3. Huh? We need it, class one. After this. Yeah. I don't really like that. Don't worry, that was wrong. So x is less than negative 2 together with x is more than or equal to 2/3. Oh. All right, last one, the logs, and we're done. The logs is the same base. This question had no PMI. No, I didn't. PMI doesn't always come. Oh, the newest thing, probably not the hardest thing. Hardest thing in pure maths is probably the trick could be trig calculus. Questions just vary. Sometimes the way they ask it. Right? Like sometimes you could get a hard PMI. You could get a hard one. Yeah. It's the way they ask it. Sometimes you get easy question and get a hard question. But they must give all the hardest. They look for the hardest. You must give all the other 2 pass, 3 pass. Last question and we're done, right? Right, for homework, please review your basic trigs, right? How to solve a trig, identities. Right, there aren't much more. There's about 4 or 5 more identities in unit 2. Well, according to how you write it. Well, I'll show you if you're adding cosec and sec here. Right, so apply the rules quickly. Log 5, addition means multiply. And 1 is really log 5, 5. Right, drop off the logs. X plus 2 by x plus 6 is equal to 5. So x squared plus 8x plus 12 minus 5 is 0. X squared plus 8x plus 7 is 0. X plus 7, x plus 1. So you get x is minus 1 and minus 7. Right, so the answer is no valid solution. Right, actually minus 1 could work in this question. You know, when I get negative values, there's no solution, right? If you put minus 7 in here, it wouldn't work because you'd have to find log of a negative value. But if you plug minus 1 in there, it will work, right? So I shouldn't say no valid solution, right? I should say only this one not valid. Minus 1 could work in that equation, okay? Minus 1 could work in that equation there. All right, so nice. That's it for today. Right, next day we start trigs. Trig will take us a while, right?